Hey GED students, I got this problem on Facebook from a student, Zan. They actually got it from my GED math crash course, and I guess it kind of proves that I'm a jerk because it's a pretty tricky problem. Let's take a look at it. Okay. It says a town's municipal water tower is a cylinder. Oh, a cylinder. As soon as they say cylinder, that's a math word I should definitely know. I know that I'm kind of here in the land of my 3D shapes, right? Cylinder is one of my 3D solids. It looks like an oatmeal container, right? Cylinder's got a circle at the top, a circle on the bottom, and then it goes straight up and down from there. Okay, so it's a cylinder 30 meters high. Okay, let me label my 30 meters high and 25 meters in diameter. Remember that the diameter is a line that goes through the center of a circle from end to end. And so there's the diameter, which we said was 25 meters. Just going ahead and visualizing what's going on. Now it says if there are about 264 gallons in a cubic meter, how many gallons does the tank hold? Okay, first thing I should ask myself, I'm in the land of 3D solids, obviously, but we have different ways that we measure 3D solids. You know, we either look at the surface area of a 3D solid, that's its covering, or the volume of a 3D solid. That's to fill it. So I need to go looking in my word problem for some clues about which is going on here. So here's some things I know, okay? One thing is that I'm looking for, how many gallons of water my tank holds. Well, where do I put water? Obviously, the water isn't on the outside of the tank. It doesn't cover the surface area of the tank. The water goes in the tank and fills it. And then there's some more language there. It says how much does the tank hold? Again, we're talking about that tank holding that water. That's another really good clue. I'm talking volume. Some more good clues is I see some units here. Gallons and cubic meters are both units of volume. They tell you how much something holds. They're three-dimensional measurements. It's especially clear on a cubic meter. Okay, so tons of great clues that I'm talking volume. And volume of what? Well, they told me the tank was cylindrical. So volume of a cylinder. So first thing I would do here is hit up my GED formula sheet and look up the volume of a cylinder formula. About halfway down the page, you'll find those 3D shapes. The section is volume and surface area. Make sure you grab the formula that starts with a V, not the one with an SA. That's the one for volume. And let's take a look at it. It says volume of a cylinder is equal to pi, and then I see r squared shoved up against it, so times r squared, and then an h shoved up against it, so times h. So that's volume is equal to pi times the radius squared times the height. Now, let's plug in what we know. Now, we are looking for the volume of this sucker. How much water it holds is volume. So V is the mystery. It's the unknown, so it will remain a letter. Pi is a long, ugly number, but the good news is right there on the formula sheet, right at the bottom of that section we're looking at, you can see they tell you pi is approximately 3.14. You can go ahead and use that decimal approximation 3.14 for pi. That's fine. Now be careful though, because the next thing after pi that I need in the formula is r, the radius. And I have a lot of students who just plug in whatever random numbers that they find. And so the biggest mistake I'll see on one of these problems is students just plugging in that 25 meters. But careful, they said that 25 meters was in diameter, not the radius, the diameter. Diameter and radius are two different measurements. So, super duper important that I plug in the numbers I need. So you have to know, it's not on the formula sheet, how to get from the diameter to the radius. And so what you're supposed to know is that the diameter goes all the way across a circle, but the radius only goes halfway across that circle from the center to the outside. So if I want to get my radius, what I'm going to have to do is I'm going to have to take that diameter of 25, divide it into two equal pieces. I'm going to get half of it. And then I find out that the radius is, 12.5? Yeah, 12.5 meters. So I'm going to plug in 12.5 for my r. Notice I do it with parentheses. I close the parentheses and then I square. Very good habit. Okay, and then next I need the height of my cylinder. Yay, that one was obvious. It said it was 30 meters high. I'll put my height in at 30 meters. Nice. Now, look at the right-hand side of that formula. There's no letters left. It's all numbers. And so I can just plug that entire expression into my TI calculator. Yay, and I will. I'll put 3.14. I'll open up a parentheses, type 12.5, close the parentheses. And then to get this little square, the easiest way to do that is to hit the x squared key. So x squared, and then open up a parentheses again, 30, close parentheses. And I get this long, ugly number, 14.718.75. But guys, we got to talk about this number because this is 14,718.75. What? Units are so important in geometry, and students just struggle with units so much. So just think about this. All of my dimensions here were meters. It was 25 meters and 12.5 meters and 30 meters. That means my volume is currently in cubic meters, which is what I would expect. If I'm working with meters times meters times meters, I'm going to get cubic meters, okay? But they don't want my final answer in cubic meters, and that's what made this problem so tricky for poor Zan. This little statement threw her. If there are about 264 gallons in a cubic meter, all right, we want to put it into gallons. So this is confusing because right now I'm in cubic meters, but let's think about this just on a small scale. Okay, so I know that 1 cubic meter has 264 gallons in it. And then another cubic meter has 264 gallons in it. And then another cubic meter has 264 gallons in it. In fact, each one of those 14,000 some odd cubic meters have 264 gallons in it. So I'm going to have 264 gallons 14,000 times. I'm going to say that again. Listen to my language. I'm going to have it 14,000 times. And so what am I going to need to do here? I am going to need to multiply. I'm going to need to take that answer that I got and times it by the 264 gallons that I have in each one of that cubic, of those cubic meters. Okay, so let's do that. Let's times our answer by 264, and we're going to get something disgusting, and that's okay. And so what I get here is 5750 gallons. I can't even say this number until I put my commas in. Let me put my commas in. Starting from the back, 1, 2, 3, comma, 1, 2, 3, comma. There we go. So 3,885,750 gallons in that tank. And if that sounds like a lot to you guys, this is the whole town's water supply. Okay. You know you're about to take a shower today and use up how many of those gallons. They need to keep a lot of them in reserve. Okay. That being said, let me just say to you, this is pretty much like expert level of geometry for the GED. You might get one this hard, okay? So give yourself a little bit of a break if you go, oh my gosh, this problem was like expert level. I don't know if I can get this. That's okay. You don't need to get them all right to pass the GED. Like I said, this is as challenging as they get. But, you know, if you're looking for that college ready score, if you are looking to go to college, then having geometry mastered to this level is super useful. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.